Hello everyone. Today I'll be going over the types and purpose of sliding bearings, the types and purpose of lubricants, and we'll be going over three different types of lubrication, and we'll be specifically diving deep into hydrodynamic lubrication. Firstly, we'll talk about bearings. When applied to a machine or structure, a bearing refers to the contacting surface through which a load is transmitted. So for example, if we have a triangular ruler and pretend it's attached to a machine of some kind, the forces from this pencil will be moving against the triangle, therefore making this triangular ruler a bearing, as the force from the pencil is being transmitted onto this triangular ruler. In this course, we will be analyzing sliding bearings. Sliding bearings require direct sliding of a load. So in the example where I was showing the triangular ruler, the pencil banging against the edges of the triangular ruler, which was the bearing, is actually a sliding bearing. There are two types of sliding bearings. One of them is a journal sliding bearing, which supports radial loads, so moving around. So in my example of the pencil moving around the triangular ruler, that was an example of a journal sliding bearing, as a pencil was moving around the bearing. Whereas thrust bearings support axial loads. As we are in automotive engineering technology, let's take a look at an engine to figure out where journal bearings and thrust bearings are. So as we can see, this crankshaft is moving around the inside of the connecting rod, but it's rotating inside. This means it is a journal sliding bearing as it's supporting radial loads. Then as we move to the side here, to support axial movement of the crankshaft, there are thrust bearings in between these crankshaft lobes here to support the axial loads. A bearing from our engine would look like. So the crankshaft would be rotating in here, and its load would be transferred onto this journal bearing. And the connecting rod, which is outside of this bearing, is connected to the piston. And we can see here that when the crankshaft rotates, it transfers its radial loading onto the bearing. Now let's take a look at lubricants. A lubricant is any substance that minimizes friction. We will be taking a look at two methods of lubrication. One of them is oil. Oil is a flow-based lubricant, so it moves around and it lubricates a machine. The second type of lubricant is grease. Greases are usually thick lubricants that usually stay in position and are used particularly when frequent lubrication is difficult or costly. There are three different types of lubrication. The first one and the worst one is boundary lubrication. It is the worst because there is extensive local contact between the two members, meaning the coefficient of friction is high, defeating the whole point of lubrication. The next one is mixed film lubrication. There is a little bit of surface contact, making it not ideal. And then the best form of lubrication is hydrodynamic. In this case, the surfaces are totally separated, meaning they have a really low coefficient of friction. This makes it ideal to use in machines which need to move a lot, for example, our engine. Going in deeper, we can see how hydrodynamic lubrication is obtained. Firstly, the shaft is not moving and there is a lot of contact. In this form, this would be boundary lubrication. As the shaft starts to rotate, speed picks up and there's a pressure buildup as the oil flows around, meaning that this is the intermittent lubrication or boundary lubrication. Then, as the speed of the shaft achieves a high enough speed, then the oil flow will completely lift or separate the two members, resulting in hydrodynamic lubrication. There are three basic parameters which influence the type of lubrication and the coefficient of friction. The first one is viscosity. The higher the viscosity, the lower the rotating speed is needed to float the two members in order to achieve that hydrodynamic lubrication. The second is speed. Once our shaft reaches a high enough rotating speed, it will lift off the bearing and will allow oil to flow underneath, achieving hydrodynamic lubrication. The last value we need to consider is bearing unit load. This is calculated by our weight of the shaft divided by the area, the rectangular area of the shaft. The important thing to consider here is that the higher the bearing unit load is, the harder it is to have hydrodynamic lubrication, as the weight of the shaft pushes down on the bearings more, making it harder to lift up and achieve the separation between the two members. To summarize, we need three things in order to obtain hydrodynamic lubrication. First thing we need is relative motion between the two members. The speed will be high enough to carry it off and obtain hydrodynamic lubrication. The second is a wedging action in order to have that pressure buildup to lift the shaft off and prevent any kind of contact. And the last one is a suitable fluid type, so we need to have a high enough viscosity so that it can create this pressure to flow between the members and the bearing. All these three factors will help obtain hydrodynamic lubrication.